Okay guys, up to this we studied about the kinetic theory of gases. We completed the part of kinetic theory of gases. Now, especially we are going to study about the radiation. Before that, what is meant by the radiation? Actually, in 11th standard, you studied the methods of heat transfer or modes of heat transfer. There are different modes of heat transfer. These modes of heat transfer are convection, conduction, and radiation. Now, we know about the conduction and convection. They require the material medium. Or in this mode of heat transfer, there is a need of material medium. When there is a material medium, then we can transfer the heat by the conduction method and convection method. Now, conduction method, actually we know heat is transferred from particle to particle. It is called as the conduction. And convection, actually particles are transferred from one place to another place. When we are heating the water, now water molecules are transferred from bottom place to top place, and upper molecules reaches to the bottom. Thus there is a heating process. In this method, actually we are transferring the molecules or particles from one place to another place, and by using this method we are transferring the heat. This is another method of mode of heat transfer. Convection and conduction. Convection and conduction requires the material medium for the heat transfer. And third type or third mode of heat transfer is radiation. In radiation, actually there is no need of the material medium for the heat transfer. Heat is transferred from one place to another place without material medium. There is no actual contact, or there is not actual contact of the bodies, or in other words we can say that bodies are not in actual contact. Still the heat can be transferred from one place to another place. This is called as the radiation. Now, in radiation, generally we are observing the best example of this radiation. Light comes from the sun to the earth. This is the example of radiation. It does not. There is no need of the material medium for transferring this light from sun, or heat is transferred from the sun to the earth's surface. There is a vacuum between this path. These radiation by the radiation method, heat can be transferred through vacuum also. Now we want to see about the radiation. Radiation is the fast method of heat transfer. By using the radiation, we can transfer the heat fastly. We can transfer the heat faster. Now in radiation, actually in radiation heat is transferred, and this heat is in the form of electromagnetic wave. Now heat is in the form of electromagnetic wave, and this electromagnetic waves can transfer through the vacuum as well as through method. Thus this heat is transferred in the form of electromagnetic wave. Now it means that this radiation is in the form of electromagnetic wave, and this is the third mode of heat transfer, and we shall discuss or we are discussing about the radiation specially. Now radiation is also, we can say that actually it is the thermal radiation. When body absorbs the heat, its temperature increases and it becomes a source of radiation. It is known as the thermal radiation. And what happens about the thermal radiation? When body, suppose this is the body, when it absorbs the heat, this body also emits the heat. And this heat or this energy is known as the thermal radiation, or this energy is emitted in the form of thermal energy. Now we want to see about the thermal energy. When thermal energy or when radiant heat is incident on the body, when radiant heat is incident on the body from this thermal radiation, we are going to study about the absorption, reflection, and transmission. Now these are the terms related with the radiant energy. This is the radiant heat or radiant energy, or we can say this as the thermal energy. Thermal energy, when we are considering thermal energy is incident on the body. Now these quantities absorption, reflection and transmission plays the important role. Now when radiant energy is incident or when heat is incident on the body, this thermal radiation or thermal energy is incident on the body. We can say this as the radiant heat is incident on the body, because body radiates this heat. That's why it is called as the radiant heat also. Now thermal energy, when it is incident on the body, now partly it is absorbed by the body. Partly it is absorbed by the body, partly it is reflected by the body, and partly it is transmitted through the body. Means when we are using the different types of objects, actually all energy is not absorbed by the body, all energy is not reflected by the body, all energy is not transmitted through the body. Generally, ordinary body partly absorbs heat, partly reflects energy or heat, and partly it is transmitted through the body. Now we want to study about these quantities, the terms related with the ability of this absorption, ability of reflection, and ability of transmission. These quantities are known as the coefficient of absorption, coefficient of reflection, and coefficient of transmission. Now we want to concentrate on these quantities: coefficient of absorption, coefficient of reflection, and coefficient of transmission. Now suppose or consider Q is the heat, total heat, or Q is the total heat or total radiant energy incident on the body. Q is the total radiant energy incident on the body. Now QA is the radiant heat. QA is the radiant heat which is absorbed by the body. When total energy is incident on the body, partly it is absorbed. Suppose QA is the radiant heat absorbed by the body, or thermal energy absorbed by the body. Now QA is the radiant heat absorbed by the body. QR is the energy or thermal energy radiated by the body, or radiant heat reflected by the body. And QT is the radiant heat transmitted through the body. Generally, this is the radiant energy incident on the body. Now, partly it is absorbed, partly it is reflected, and partly it is transmitted. But according to law of conservation of energy, energy remains constant. Therefore, we get this total radiant energy incident on the body. It is equal to energy absorbed by the body plus energy reflected by the body plus energy or heat transmitted by the body. Therefore, we can write the equation as Q is equal to QA plus QR plus QT. Q is equal to QA plus QR plus QT. Now, by dividing with the Q on both sides, when we are dividing with the Q, we get this as the Q upon Q. It is equal to QA plus QR plus QT upon Q. But Q upon Q, it is equal to 1. Now we can write this as the QA upon Q. QA upon Q plus QR upon Q plus QT, QT upon Q. Now this ratio is called as the coefficient of absorption. This QA upon Q, it is called as the coefficient of absorption, and it is represented by small a. Now A represents the coefficient of absorption. This is QA upon Q. Plus, now coefficient of reflection, it is represented by small r. It is represented by small r. This r is equal to QR upon Q. Plus, this coefficient of transmission, it is represented by TR. Suffix is taken as the TR, transmission. Generally, we are using T for time, but suffix is used as the TR in order to indicate the coefficient of transmission. Now, we get this 1 is equal to A plus R plus TR. Means coefficient of absorption, coefficient of reflection, and coefficient of transmission. From this, we can define the coefficient of absorption, coefficient of reflection, and coefficient of transmission. Now, coefficient of absorption. Now, coefficient of absorption, from this we can easily define the coefficient of absorption. This coefficient of absorption is, it is equal to QA upon Q. Remember this relation, this A is equal to QA upon Q. This is the coefficient of absorption. Now, it is the ratio of these two quantities. From this we can define this coefficient of absorption as, now coefficient of absorption, it is equal to QA upon Q. We can define this as the coefficient of absorption, and this coefficient of absorption we can define this as the ratio of radiant heat absorbed by the body, ratio of radiant heat absorbed by the body to the radiant heat incident on the body. Total radiant heat incident on the body, this ratio is called as the coefficient of absorption. Now, this coefficient of absorption, it is equal to QA upon Q, which is equal to A, and this is the coefficient of absorption. How we can define this coefficient of absorption? The ratio of radiant heat absorbed by the body to the radiant heat incident on the body. Radiant heat incident on the body, it is called as the coefficient of absorption. Next is coefficient of reflection. Actually, this coefficient of absorption, it is also called as the absorptivity absorptors. This coefficient of reflection is also called as the reflectance, and it is equal to R is equal to QR upon Q. Again, simply we can define this as the ratio of radiant energy or the ratio of thermal energy, ratio of the amount of thermal energy reflected by the body, thermal energy reflected by the body to the total thermal energy incident on it. This ratio is called as the coefficient of reflection. The ratio amount of radiant heat or thermal energy, or radiant heat is reflected by the body to the radiant heat or total thermal energy incident on it. This ratio is called as the coefficient of reflection. And third is coefficient of transmission. Now this coefficient of transmission, it is represented by TR is equal to QT upon Q. Now this coefficient of transmission, we can define this as the ratio amount of quantity of radiant energy or thermal energy transmitted through the body to the total radiant energy or thermal energy incident on it. This ratio is called as the coefficient of transmission. Thus, there are three definitions: coefficient of absorption, coefficient of reflection, and coefficient of transmission. Actually, these are related with the thermal energy which is absorbed, transmitted, and reflected by the body. From this quantity, we can define this quantity. Actually, we are taking the ratio of this quantity with the total radiant energy incident on it. This ratio is called as the coefficient of absorption, coefficient of reflection, and coefficient of transmission. Now, from this we can say that if actually there is a terms related with the transmission. If Tr is equal to 1, if Tr value is 1, if means total energy being incident on the body, it is transferred to transmit, or it is transferred to pass this energy through that body or object. In this case, coefficient of transmission is 1. When coefficient of transmission of object is 1, then we can say that it is a perfect transmitter. It is a perfect transmitter. Actually, the body through which total energy is transmitted, actually it is a bad absorber and bad reflector. It is a bad absorber and bad reflector. In this case, we get this A plus T, A plus R is equal to 0. A plus R is equal to 0 and TR is equal to 1. This body is called as a perfect transmitter. Now, this transmission is depend on the body. Sometimes some bodies partly transmitted this energy. Sometimes this bodies partly transmit the thermal energy, and sometimes this energy cannot pass through the body. From this we can define the two quantities, that is the diathermalous substance. Now diathermalous substance, and second is athermalous substance. Diathermalous substance and athermalous substance. Diathermalous substance and athermalous substance. Now diathermalous substance, actually these are the substances through which this radiant energy or thermal energy can pass. When this energy can pass through this substances or object, these objects are called as the diathermalous substance. Means energy, the substance which allows the radiant energy to pass through it, it is called as the energy is transmitted. Energy is transmitted through these bodies. Energy is transmitted through these bodies, and these bodies or objects are called as the athermalous substances. Means this radiation can easily pass. Radiation can easily pass through the diathermalous substances. Now examples of these diathermalous substances are glass, quartz, sodium chloride, sodium chloride, air, hydrogen. These are the examples of diathermalous substances. Through this, it is not equal to 0. It is not equal to 0. Means this energy can through this energy can transmitted. Therefore, it is not equal to 1, or it is not equal to 0. In this case, this R plus A plus R, A and R have also some value. Now actually in case of diathermalous substances, this energy is nearly equal to the 1, but it is we can write this as the TR is not equal to 0, but in this value may be 1. Therefore, we can say that in case of diathermalous substances, it is a good transmitter but poor absorber and poor reflector. It is a poor absorber and poor reflector. Now next is ether-manous substance. Next is ether-manous substance. Ether-manous substance. These are the objects through which this heat radiations or thermal energy cannot pass. Thermal energy cannot pass, or these substances does not allow the thermal radiation to pass through it. These substances are called as the ether-manous substances. Now examples of this ether-manous substance, in this case actually this TR is equal to 0. In this case this TR is equal to 0 and this A plus R is equal to 1. A plus R to 1. Now diathermalous substances and ether-manous substances. Diathermalous substances and ether-manous substances are these substances. Diathermalous substance, that is the substance through which energy is transmitted. Energy can easily transmitted or energy can pass through these substances or objects. These are called as the diathermalous substances. And ether-manous substances, the radiant energy cannot pass, or this substances does not allow the transfer of heat through this body. These are called as the ether-manous substances. Example is water is also ether-manous substance. Now wood, copper, these are the ether-manous substances. Now while diathermalous substances are glass, quartz, sodium chloride, air, hydrogen, these are the diathermalous substances. Now we know when this TR is equal to 1, it is called as the perfect transmitter. It is called as the perfect transmitter. In case of bodies, when coefficient of reflection is maximum, this coefficient of reflection is 1. In this body is called as the perfect reflector. It is called as the perfect reflector. Now perfect reflector is the body. Actually it also possesses the poor absorber and poor, actually this perfect reflector is poor absorber and poor absorber and poor transmitter. This body is the poor actually it acquires the poor transmission and poor absorption, but reflection is maximum and it acts as the perfect reflector. And third is each body absorbs the maximum energy. Each body absorbs the total energy. In this case, this coefficient of absorption is 1. In this case, coefficient of absorption is 1. Therefore, such type of body is called as the perfect black body. Perfect black body. It absorbs the all radiant heat, radiant energy incident on it, or all thermal energy which is incident on it, and it absorbs maximum energy, and therefore it radiates also maximum energy, or emission is maximum. When body absorbs maximum energy, it also radiates the maximum energy. Therefore, coefficient of absorption is maximum. In this case, this body is called as the perfect black body. Now, this is about the radiation. Now, radiation is the third mode of heat transfer, and this is the fastest mode of heat transfer. Generally, we are transferring the heat by three modes: conduction, convection, and radiation. Conduction convection requires the material medium for the transfer of heat, while radiation it does not require the material medium for transferring the heat from one place to another place. Now in this chapter we are concentrating on the radiation. Now radiation is actually it is the transfer of heat in the form of electromagnetic wave. These are faster, they does not require, this rays does not require the material medium. Therefore this radiation can be observed in vacuum also, or waves can be traversed through the vacuum as well as medium. Now when energy is absorbed by the body, its temperature increases. So that it also radiates energy. This it is known as the thermal radiation. Actually, it radiates the energy. This energy is called as the thermal energy. Now, when there is a thermal radiation, means when energy is incident on a body, partly it is absorbed by the body, partly it is reflected by the body, partly it is transmitted by the body. Therefore, when we are keeping the body in radiations or in heat, at that time it absorbs some energy, reflects some energy and transmits some energy. From this we can study the quantities such as absorption, reflection and transmission. Now we have also the terms related with this absorption, reflection and transmission. These are known as the coefficient of absorption, coefficient of reflection and coefficient of transmission. Actually it is the ability of body to absorb. This is the ability of body to reflect, and this is the ability of body to transmit this energy. These abilities are represented in terms of coefficient of absorption, coefficient of reflection and coefficient of transmission. Now when suppose Q is the heat, radiant heat incident on this body, Q is the radiant heat or radiant energy absorbed by the body, or thermal energy absorbed by the body. QR is the thermal energy reflected by the body, and QT is the thermal energy transmitted by the body. Now according to law of conservation of energy, incident energy is equivalent to the used energy, that is Q is equal to QA plus QR plus QT, or we can say that energy remains constant. Therefore Q is equal to QA plus QR plus QT. By dividing with Q on both sides we get Q upon Q and this upon Q. Therefore we get this as the Q upon Q is 1. Q upon Q is 1, which is equal to QA upon Q plus QR upon Q plus QT upon Q. Thus we get this 1 is equal to A plus R plus TR. Now this A is the coefficient of absorption, R is coefficient of reflection and TR is the coefficient of transmission. Now this A plus R plus TR, it is equal to 1. From this coefficient of absorption we can define this as the ratio of amount of or quantity of radiant heat absorbed by the body to the radiant heat incident on the body, or total radiant heat incident on the body. This ratio is called as the coefficient of absorption. Now ratio of quantity of radiant energy reflected to the quantity of thermal energy or radiant energy incident on it, total quantity of radiant energy incident on it, this ratio is called as the coefficient of reflection. Now coefficient of transmission, it is the ratio of amount of or quantity of radiant heat transmitted to the radiant heat incident on it, or thermal energy incident on it. This ratio is called as the coefficient of transmission. Also we are concentrating on the transmission. When this TR means coefficient of transmission is 1, it means that total energy is transmitted through the body. In this case A plus R is equal to 0. It means that it is a perfect reflector, but we can say that perfect reflector is a poor absorber, or It is a poor absorber or poor reflector. When reflection is maximum at that time, these are not absorb energy or reflect energy. Now, diathermal substance and athermal substances are dependent on the transmission of energy. When the objects through which this radiant heat or thermal energy can pass, these are called as the diathermal substances. And in this case, actually, this Tr is not equal to 0. It means that the diathermal substances are poor absorber and poor reflector. Now, examples of the diathermal substances are glass, quartz, sodium chloride, also air, hydrogen. These are the examples of diathermal substances. Athermal substances, they are substances through which this radiant heat cannot pass. These are called as the athermal substances. In this case, Tr is equal to 0, but A plus R is equal to 1. Now, examples of this diathermal substances are wood, wood, water. These are the examples of the athermal substances. Now, also, when coefficient of reflection is maximum, these are the good reflectors. And in case of it, coefficient of absorption is 1, means maximum energy is absorbed by the object or body, or total energy which is incident on the body. This total energy is absorbed by the body. It is called as the perfect black body. Now, actually, all these quantities are the ratios of thermal energy. A, R, and Tr. These are the ratios of thermal energy. Therefore, all these are dimensionless quantities. Because these are the ratios of same quantity. This is heat upon heat. Actually, energy unit of heat. Heat is same. This unit of heat is same. We can cancel this units. When we are cancelling units, actually it is unitless quantity. All these are unitless quantity because these are the ratios of thermal energies. Now, lastly, we concentrated on the perfect black body. Now, this A, R, and Tr, these are depend on the temperature of the body or nature of the body. These are also depends upon the wavelengths. Of the heat radiation. Now, lastly, we already studied this perfect black body. Now, what is the perfect black body? Now, perfect black body. Which body is called as the perfect black body? Now, definition of this perfect black body is when body or when radiant heat is incident on the body, it absorbs the total energy or entire energy is absorbed by the body. When radiant energy is incident on it, this body is called as the perfect black body. It is called as the perfect black body. But such type of perfect black body does not exist in the universe. Therefore, lamp black bodies are acts as the perfect black body. Now, in case of perfect black body, coefficient of absorption is 1, while this R plus Tr is equal to 0. Means total energy is absorbed by the body. Energy is not reflected as well as transmitted through the body. Therefore, its coefficient of absorption is 1. Actually, this absorbs the more energy. Therefore, it radiates more energy. Or there is a emission of energy maximum. Means when it absorbs the more energy, therefore it emits the more energy. Its temperature increases. That's why it emits the more energy. And lamp black, actually this lamp black acts as the perfect black body. Now the actually number of perfect black bodies are designed, but this lamp black absorb the energy near about the 97%. 97% energy absorb this lamp black, and this acts as the perfect black body. For practical purposes, we are using the perfect black body. This lamp black acts as the perfect black body, because perfect black body does not exist in the universe, and we are using the, so for practical purposes, lamp black body, it absorbs the energy near about 97%. When we are when energy is incident on this perfect on this lamp black, it absorbs 97% energy. But when it suffers or when it undergoes the number of reflections, it absorbs the total incident energy. That's why it acts as the perfect black body. Now we can also study about this black body. Now consider the two bodies. Consider the two bodies. Consider the two bodies. Actually, these are the opaque. These are the opaque to the thermal radiation. These are opaque to the thermal radiation. These are opaque to the thermal radiation. It means that this radiation heat is not transferred toward this or towards this. Means these are opaque to the thermal radiation. Now these are the two bodies. One is ordinary body, while other one is nickel polished body or silver polished body. It is the nickel polished body, while this is the black painted body. This surface is painted with the black. This is the surface, black painted surface, while this is the nickel polished or silver polished surface. Now these are these surfaces of these bodies are same. These are kept at the same temperature. These are kept at the same temperature. Means there is no thermal radiation. There is no thermal radiation or heat is not absorbed by this body or this body from this body. Means there is no exchange of heat between these two bodies. This is the nickel polished or silver polished, while this is the lamp black surface. Now all bodies radiates energy. All bodies radiates energy. Now in case of nickel polished body, there is a maximum or more energy. When energy is incident on this body, then this mostly this energy is reflected. Mostly energy is reflected, and small quantity of energy absorbed by this body. And when in case of black painted body, mostly energy is absorbed by the body. Mostly energy is absorbed by the body, and small quantity is reflected from this body. From this body, small quantity of radiant energy is reflected. Actually, in each body, in case of each body, the rate of absorption is equivalent. It is equal to the rate of emission. Rate of absorption is equivalent to the rate of emission. Therefore, their temperatures remains same. Their temperature of this body remains same. In case of polished surface, it absorbs the less energy. Therefore, emission is also less. In case of black painted body, it absorbs more energy. Therefore, it emits more energy. Means emission is also more. Absorption is more, therefore emission is also more. And in this case, absorption is less, therefore emission is also less. Therefore, its temperature remains same, or its temperature remains constant. Otherwise, if rate of absorption is greater than the rate of emission, then temperature of body increases. And if rate of absorption is less than the rate of emission, means energy absorbed is smaller than the energy emitted by the body. In this case, temperature of body decreases. Now, actually, when body absorbs the more energy, its temperature increases. In this case, its temperature increases and it radiates the energy. Just to concentrate on this polished surface and black surface. In case of polished surface, we know there is a less energy absorbed by the body and more energy is reflected. In this case, more energy is absorbed and less energy is reflected. When energy absorbed is more, its emission is also more. Now, next part we will discuss in a next lecture.